this talk, I wanted to share a little bit of the lessons learned over the past 18 months of building large language model applications. So this is something that we think is pretty important, is that as teams are starting to incorporate Gen AI into their platforms, what did we learn during our journey doing so? So we're going to go through a number of different components. We're going to talk a little bit about the conversational AI space, sort of what the product that we built was, thinking about observability, thinking about prompt editing as a component of observability, talking a little bit about the prompts that users write on our platform, and then finally getting into some graphs and questions. So Voice is an AI agent platform, allowing you to build different types of workflows, both with large language models, classification models, and API-based responses. We have a number of different components of it. We have managed RAG, CMS editor, allowing you to pick and choose the tooling that you want to build as a team. And the key focus that I'll be talking about today is the actual prompting and customization of these features. Okay, so we talked a lot about observability at this conference, and I think it's important to ask the question, what is observability and why do users care? So when you're building a large language model application, why do people want to have observability? So there's a great engineering leader and observability leader, Charity Majors, who works on an observability platform, and her definition is that observability is about unknown unknowns, trying to figure out what's actually going to break when you don't know what's going to break. Now, this is great for engineers or people working at the low level to try to debug a system. But the challenge is right now, the AI space, everybody's sort of trying to figure things out. People are tinkering, playing around with things. So knowing what the unknown unknowns are is a decent definition, but people don't necessarily know what they want to build. So what kind of observability system do you need? Now, if you've used any kind of observability tool in the past, there's a lot. This is a fact that I made up, but I've used quite a few. And when you try to go through the different dashboards, all the different metrics, integrations, you're like, what is going on here? There is so much, some more than others, but it's really complex to actually understand what's happening in an observability tool, especially if you haven't used it. So you get airdropped in, you want to figure out what's broken, really hard to do so without expertise. So my definition of observability is building a mental model about a certain problem or a task that you're solving. So if you're building a certain application, you want to be able to easily figure out what's wrong. And that requires a good mental model, whether it's getting a mental model through a graphical interface, a CLI, or graphs and pretty charts, right? There's different ways we as people get a good mental model. And what becomes challenging is when you make things too complex, you deteriorate that mental model. And now you're focused on tooling and complexity rather than actually solving the problem. Now, the challenge of simplicity in mental models is that this doesn't always work. So originally, when we built out our RAG integration into Voiceflow, we had this step. And in this step, you basically had one spot where you could put in variables, different types of prompts, and access the information from the knowledge base. And the reason that we put one box is that we wanted to make it as simple as possible. For people who are building applications, just type your prompt here. Now, what's challenging here is that RAG has two components, right? It has retrieval and it has generation. So when people are putting different types of variables, different types of prompts, this is actually affecting both states, retrieval and generation. So we compromised complexity and power for the purpose of simplicity, and we had to revert that decision, right? Because the data came in and said that people are trying to do things that don't work with a single text box for prompting and variables. And the other challenge here was that people were expecting a ChatGPT style experience. They could ask any kind of question, get any kind of result. But when you're building a production application, that doesn't actually work, right? ChatGPT is a little bit of a red herring for user experiences. And some of the challenges that we were getting is that when users were prompting, they were expecting some kind of general search or self-awareness about a system, right? They didn't fully understand how the system was working because there was no observability in that regard, how we actually rendered it. So lesson number one from this when you're building products is explainability is better than simplicity. It's good to keep things simple, but always have a way for users to actually figure out what's going on. Whether it's through a test tool, prototype tool, rendering, or so forth, every application is going to be slightly. Now, the reason why this is important is that users will start doing things like this, right? So they start writing these really complex prompts that, if you're building your product, might not make sense, right? So they're saying, okay, I have a knowledge base called product or reg system with different segmentations of data, different tags, and so forth, either by customer or tag. We have this component called tagging for metadata filtering. They'll be like, search this information using this information, right? They don't understand how variable interactions necessarily work. They're assuming there's some kind of entity recognition. So whenever you allow people to customize and do these kind of features, right, you're always going to get more and more questions, right? So sometimes it's better to not let people customize and just have them skim over that and assume that it works, rather than opening up this whole can of worms that might not actually be great for a problem. Now, talking more about prompting, we expose prompts in the system in a number of different ways. So you can see here there's different types of steps. We have two different types of steps, a set AI step, which lets you say the LLM responses to a variable, and a response AI step, which basically sends it back to the user. And you can use either a generic model or use a RAG-based system. We also have a few other capabilities here, for example, a fallback mechanism. So whenever the model or the system doesn't understand what's happening, we'll revert to a prompt or language model. We also have a feature that we released a few months ago to do routing with a combination of encoder classification models and LLMs. So we have a lot of surface area where users can prompt, and users need to be good at prompting in different scenarios. Now, the other challenge is when users prompt in a system, is this the prompt that gets rendered at the very end of their application? And the answer is no, because things are more complex than what they seem. So for example, within our reg-based system, you have this little preview configuration where you can upload your documents, ask a question, see the citations, customize the different prompts. Now this gets really tricky because you're not asking questions in the vacuum. A system is always stateful in some kind of way, right? If you're a customer building a customer support agent, the first question that somebody asks is going to have a very different state if they're asking questions before. So now you need to be able to simulate this kind of state, this kind of memory within your conversation. So users were getting confused because the answers they were getting from a stateless answer versus a stateful answer were quite different, right? So this created some complexity for us, and it led to us actually removing memory as a functionality from our reg-based system because it was causing too much confusion for users on how things are being built. So this isn't our built-in step. You could still pull in memory and add it to the prompt manually. But for that user who was looking for simplicity, we removed it because it caused confusion between expectations. The other component here is that when you're building a prompt, there's higher level operations that you need to do. So in our case, when you're retrieving something from the reg-based system, sometimes you don't find what you're looking for. And what we did is that we have an ability to actually follow a flow or workflow that lets you go down a certain path if it's a not found operation. This means that you need to inject some kind of not found command into the prompt, right? And detect that as part of the response. And that's what we did, but it means that we are injecting additional information into here. Same things with citations, right? So we need to inject some kind of citation extraction into your prompt in order to be able to retrieve that information. So now you get this asymmetry of what the prompt is being written in the editor versus what's actually being run at runtime, creating some differences as well. So lesson 3, and I call it A, you need to figure out where you're going to add default behavior versus where to let users customize, and figure out how much time you spend on that default behavior. So in our case, we removed the memory because that was confusing as a default behavior. So we let users opt into that if they wanted to, rather than it being really easy to access with the problem. And then the second lesson was to make prompt wrappers as consistent as possible in your product, because users will be confused if you have similar functionality that returns slightly different results. In this case, sometimes it's unavoidable with things like state management, but we do our best. So recently we released a new feature called LLM intent classification, which I mentioned earlier. in the platform, you can fine-tune a model that will classify based on some kind of workflow or intent. So I want to order pizza, get human support, I want to track the order. And for certain use cases, adding an extra layer on top of an LLM classification worked better. And what we experimented in the UI is actually exposing this full prompt template for the user to edit. You can see some JavaScript variables in here. You see like a few shot example. It works pretty well out of the box. And when we were actually building up the system, we published some blogs because you can't fit all the information into the product, right? It's not possible to do so. So we published some blogs about it, with some graphs and emulations and a bunch of other stuff. It's on voiceflow.com/research. So we gave some customization in the tool and also inside the form of content. Now, what we learned is nobody actually edited this prompt. It worked well enough, and people were like playing around with it, trying to optimize, but it ended up working well enough. But people were really excited to just be able to see the prompt. So in your product, people might want to say, yeah, I want to see the prompt, I want to edit it, but they might not do it. They just want to work on it. So you kind of get this observability for curiosity rather than customization. That's lesson number 4. You want visibility for curiosity, not for action. So what did users actually change? This is an interesting graph. When we launched our LLM features back last year, we sort of had a number of different models that you could use. You can sort of see the history of LLMs with the original pod models, the original ChatGPT. You can see here that there's quite a bit of fluctuation of different models working well. So originally we were using Cloud Instance for our RAG-based system. When better models came out, we replaced it, and you saw that the drop there in usage and pain. Then you saw ChatGPT sort of being very consistent at the top. At the bottom here, you can see the different GPT-4 families evolving as well. So in here, what's really important to know is that when you're building a product, defaults are really powerful, so make sure that you test them out. By giving people the ability to customize, they can pick what kind of use case, what kind of prompts they're writing for your application. So we also measured what kind of changes people made into their prompting and hyperparameters. So what we can see here is we've broken it out into 3 different types of changes: changing the temperature, changing the prompt, changing the token, changing the models to support. And you can see here how different types of changes were really consistent. It's kind of interesting, it's cyclical, but not really so. So people actually changed the model the least. So the default value was most important. But actually the most changed item was the number of tokens. So we defaulted to 128 just to make sure that users weren't waiting too long for responses. This was based on user feedback, but most users ended up changing that. So as a proportion of all the changes people made, that was the most common. And changes by project. This is kind of interesting that you have this very power law distribution of like a few users changing things a lot within their projects, experimenting with prompts, iterating, changing the models, and so forth. But you get quite a bit of a long tail. I think this is the top projects being changed. So everybody's using prompts, changing prompts in very different ways. So your users' expectations will be different. So that's the talk. There's a lot of impacts on your product when you're working through making changes, exposing prompts, exposing templates. So it's quite a bit of a journey. So thanks for joining us for our last 18 months.